We're going to learn how to solve exponential equations. Now, there are two different ways to solve this. One method that only works in specific circumstances, and one method that will always work but takes a little bit more. This first example is one that will do the shortcut method. If you notice, we can write both sides as exponents of the same base. So if at all possible, we are going to try to do that. In this case, both sides can be written as a power of 2. When you have both sides as the same power, then we can just set the exponents equal to each other, ignoring the exponential part, and then solving for x. Of course, this method only works when you can actually write both sides as powers of the same base. If we look at our second example, I don't know about you, but I have no idea how to write 5,000 as a power of e. So I'm going to need another method. So, when solving a generic exponential, there are 3 quick steps that will always get you the answer. The first step is to get the exponential totally alone. Okay? So in our example, the exponential is the e to the 0.09t. We want it alone on one side of the equation, so I'm going to divide both sides by that 1,000 to get it alone. The second step to solving a generic exponential is to get rid of the exponential. And we do this by taking a logarithm of both sides. Now, which logarithm we take depends on the problem. Generically, whatever base the exponential is, that's the base we're going to take the logarithm. So this is an exponential base e, so I'm going to take a logarithm base e, which if you remember was a natural log of both sides. Okay. Now, the reason we did that is because immediately, by properties of logarithms, the ln and the e cancel, and we're just left with 0.09t equals ln of 5. The last step to solve any exponential is then to do whatever you need to do to solve for the variable. So in this case, we want to solve for t. So I'm going to divide by the 0.09. Now that is a perfectly acceptable answer here, but if you want to know a little bit better, it actually is approximately 17.88. Because in application problems, we usually want a decimal value as opposed to a more exact value that we don't understand as well.